Hi everyone, welcome back to Learn with Maktum. In the last video of introduction, we have finished what is meant by computer, what are the characteristics of the computer, and also we saw the block diagram of the computer. So today we will move on to the second part of the chapter where we will be studying parts of the computer system, what are different computer languages we have, and some of the terms like compilers, interpreters, linkers, and loaders in this video. So after this, in the next video, we will be starting with the algorithms and flowcharts. We will have an introduction to them, and then we will see the examples for the algorithms and flowchart. Okay. ಸೊ ಈ ಒಂದು ಮೊದಲನೇ ಪಾಠದ ಮೇಲೆ ನಾವು ಮೂರು ಪಾರ್ಟ್ ವಿಡಿಯೋಸ್ ಆಗ್ತಾವ್ರಿ ಆಯ್ತಾ. ಸೊ ಈ ಒಂದು ಪಾರ್ಟ್ 2 ದಲ್ಲಿ ಪಾರ್ಟ್ಸ್ ಆಫ್ ಕಂಪ್ಯೂಟರ್ ಸಿಸ್ಟಮ್ ನೋಡೋಣ್ರಿ, ಕಂಪ್ಯೂಟರ್ ಲ್ಯಾಂಗ್ವೇಜಸ್ ನೋಡೋಣ, ಮತ್ತೆ ಕಂಪೈಲರ್, ಇಂಟರ್ಪ್ರಿಟರ್, ಲಿಂಕರ್ ಮತ್ತೆ ಲೋಡರ್ ಅಂದ್ರೆ ಏನಂತ ಹೇಳಿ ನೋಡೋಣ. ಓಕೆ. ಸೊ ಫಸ್ಟ್ ಏನ್ ನೋಡೋಣ, ಪಾರ್ಟ್ಸ್ ಆಫ್ ಕಂಪ್ಯೂಟರ್ ಸಿಸ್ಟಮ್. ಸೊ ಈಗ ಯಾರಾದ್ರೂ ನಿಮಗೆ ಕಂಪ್ಯೂಟರ್ ಪಾರ್ಟ್ಸ್ ಯಾವ್ಯಾವ ಅಂತ ಕೇಳಿದ ನೀವೇನು ಹೇಳ್ತೀರಿ? ಯು ವಿಲ್ ಸೇ ದಟ್ ಕೀಬೋರ್ಡ್, mouse, right, monitor. You will say these are the parts of the computer, right? So yes, these are also right, but majorly the parts of the computer systems are classified as, first one we call it as hardware, ಇನ್ನೊಂದು ಸಾಫ್ಟ್ವೇರ್ ಅಂತ ಕ್ಲಾಸಿಫೈ ಮಾಡಿದ್ದೀವಿ. ಹಾರ್ಡ್ವೇರ್ ಅಂಡ್ ಸಾಫ್ಟ್ವೇರ್ ಇವು ಎರಡರ ಜೊತೆಗೆ there are two more components. One is the data and one more is the user. These two are also the parts of computer system. About them we will see later. First let us try and understand what is meant by hardware and software. So ಈಗ ಹಾರ್ಡ್ವೇರ್ ಮತ್ತು ಸಾಫ್ಟ್ವೇರ್ ಅಂದ್ರೆ ಏನು? ಸೊ ಹಾರ್ಡ್ವೇರಿಗೆ ಬಂದಾಗ the parts of the computer which can be touched are called as hardware. ಟಚ್ಡ್ ಅಂತಂದ್ರೆ ಅವುಗಳು ಮೆಕ್ಯಾನಿಕಲ್ ಕಾಂಪೋನೆಂಟ್ಸ್ ಇರ್ತಾವ್ರಿ, ಮತ್ತೆ ಹಾರ್ಡ್ವೇರ್ಗೆ ಸಾಫ್ಟ್ವೇರ್ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಹಾರ್ಡ್ವೇರ್ ಏನಿರ್ತಾವ್ರಿ, ಚೀಪ್ ಇರ್ತಾವ, ಅಂದ್ರೆ ಕಾಸ್ಟ್ಲಿ ಇರೋದಿಲ್ಲ, ಚೀಪರ್ ರೇಟಲ್ಲಿ ಸಿಗ್ತಾವ. ಹಾರ್ಡ್ವೇರ್ ವರ್ಕ್ ಮಾಡೋದು ಯಾವ ರೀತಿ ಅಂತಂದ್ರೆ, ಸಾಫ್ಟ್ವೇರ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ನ ಕೊಡ್ತೈತಿ ಹಾರ್ಡ್ವೇರ್, ಆ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಪ್ರಕಾರ ಹಾರ್ಡ್ವೇರ್ ವರ್ಕ್ ಆಗುತ್ತೆ. So software will be giving a set of instructions. According to those instructions, hardware will be working. So hardware works on instructions given by the software. ಸೊ ಇದಿಷ್ಟು ಪಾಯಿಂಟ್ಸ್ ನೀವು ಹಾರ್ಡ್ವೇರ್ ಬಗ್ಗೆ ನೆನಪಿಟ್ಕೋತೀರಿ. ಈಗ ಇದು ಉಲ್ಟಾ ಹೇಳ್ತೀರಿ, ಏನದು ಸಾಫ್ಟ್ವೇರ್ ಬಗ್ಗೆ. ಸಾಫ್ಟ್ವೇರ್ನ ನೀವು ಟಚ್ ಮಾಡೋದಕ್ಕೆ ಬರೋದಿಲ್ಲ, ಇಟ್ ಕ್ಯಾನ್ ನಾಟ್ ಬಿ ಟಚ್ಡ್. ಯಾವ ಕಾಂಪೋನೆಂಟ್ಸ್ ಟಚ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲ ಅವುಗಳಿಗೆ ನಾವು ಲಾಜಿಕಲ್ ಕಾಂಪೋನೆಂಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಲಾಜಿಕಲ್ ಕಾಂಪೋನೆಂಟ್ಸ್ ಆರ್ ಯುವರ್ ಸಾಫ್ಟ್ವೇರ್. ಸಾಫ್ಟ್ವೇರ್ ಅಂತಂದ್ರೆ ಸೆಟ್ ಆಫ್ ಪ್ರೋಗ್ರಾಮ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು, ಸೆಟ್ ಆಫ್ ಪ್ರೋಗ್ರಾಮ್ಸ್ ವಿಚ್ ಪರ್ಫಾರ್ಮ್ಸ್ ಅ ಸ್ಪೆಸಿಫಿಕ್ ಟಾಸ್ಕ್. ಸೊ ಈಗ ಪ್ರೋಗ್ರಾಮ್ ಬಗ್ಗೆ ನೀವು ಕಲಿತೀರಿ, ನಾವು ಒಂದೊಂದು ಪ್ರೋಗ್ರಾಮ್ ಬರಿತೀವಿ. ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದೇವೆ ನಾವು, ಸೆಟ್ ಆಫ್ ಪ್ರೋಗ್ರಾಮ್ಸ್ ಹೇಳ್ತಾ ಇದೀವಿ. ಸೊ ಪ್ರೋಗ್ರಾಮ್ಸ್ ನ ಕೂಡಿಸಿ ಏನೋ ಒಂದು ಫಂಕ್ಷನಾಲಿಟಿ ಮಾಡಿದಾಗ ಅದಕ್ಕೆ ನಾವು ಸಾಫ್ಟ್ವೇರ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಸಾಫ್ಟ್ವೇರ್ ಅಲ್ಲಿ ಅಗೇನ್ ವಿ ಹ್ಯಾವ್ ಟೂ ಕೈಂಡ್ಸ್, ಅಪ್ಲಿಕೇಶನ್ ಸಾಫ್ಟ್ವೇರ್ ಮತ್ತೆ ಸಿಸ್ಟಮ್ ಸಾಫ್ಟ್ವೇರ್ ಅಂತ ಬರ್ತವೆ. ಅವುಗಳ ಬಗ್ಗೆ ನಾವು ಮುಂದೆ ಕಲಿತೀವಿ. ಓಕೆ. ಈಗ ಕಂಪೇರಿಂಗ್ ಟು ಹಾರ್ಡ್ವೇರ್ ಇವೇನಿರ್ತಾವ್ರಿ, ಕಾಸ್ಟ್ಲಿಯರ್ ಇರ್ತಾವು, ಮತ್ತೆ ಇವೇನ್ ಮಾಡ್ತಾವು, ದೇ ಗೈಡ್ ಹಾರ್ಡ್ವೇರ್. ಸೊ ಹಾರ್ಡ್ವೇರ್ಗೆ ಗೈಡ್ ಮಾಡ್ತಾವು. ಓಕೆ. ಇಫ್ ದೇ ಆಸ್ಕ್ ಇನ್ ಎಕ್ಸಾಮಿನೇಷನ್ ದ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಹಾರ್ಡ್ವೇರ್ ಅಂಡ್ ಸಾಫ್ಟ್ವೇರ್, ಯು ಕ್ಯಾನ್ ರೈಟ್ ದೀಸ್ ಪಾಯಿಂಟ್ಸ್. In some textbook they will also be mentioning about assembly level language. So ನಾವು assembly level language ನ low level ಅಲ್ಲಿ include ಮಾಡಿ ಕಲಿಯೋಣ. Okay. So let's study about the low level language. Low level languages are easily understandable by the machine. So the language which is easily understandable by the machine is nothing but your low level language. So low level language is further classified into two categories. One is your machine level language and one more is the assembly level language. Okay. So machine level language ಅಂತಂದಾಗ ಇದನ್ನ ನಾವು ಫಸ್ಟ್ ಜನರೇಷನ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಅಂತನೂ ಕೂಡ ಕರಿತೀವಿ. ಫಸ್ಟ್ ಜನರೇಷನ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಅಂತ ಕರಿತೀವಿ. Assembly level language is also called as second generation language. Okay, so in the machine level language, we are writing the programs using the two digits. Those digits are your zeros and ones. Zero represent the low voltage, one represent the high voltage. Okay, so each instruction will be written using the zeros and ones. So the instruction consisting of two parts, one is the opcode and one more is the address. Opcode will be made up of 4 bits and your address will be made up of 8 bits. This is a pattern of each instruction. So since this language is easily understandable by the machine, and here there will be no requirement of the translators in machine level language, no need of the translators, and the programs will be directly executed by the machine itself. That's why it is called as machine level language, where there is no need of translators. Okay, coming to the disadvantages, since we are writing all instruction using the binary form, it is very much difficult for the programmers to remember the what? To remember the instructions. So when I say disadvantages, the first disadvantage is that it is difficult to remember each and every instruction. It is difficult to remember the instructions, and also it is difficult to debug the errors because everything we need to do using what? Using the binary language. So that's why it was very much difficult to remember each and every instruction, as well as it is difficult to debug the errors. So this is all you need to remember about your machine level language. So in the machine level language, we are using zeros and ones to write the instructions, and each instruction will be having a opcode which is made up of 4 bits and address which is having 8 bits. And there is no need of translators. The programs will be directly executed, and the disadvantage is that difficult to remember each instruction in binary, as well as to difficulty in the debugging the errors. Now, as the time passes, they invented the assembly level language, which is called as second generation language. Here, we started to use the symbolic instructions. We started to use the symbolic instructions. Those symbolic instructions, we call them as mnemonics. ಏನಂತ ಕರಿತೀವಿ ನಾವು ಅವಕ್ಕೆ mnemonics ಅಂತ ಕರಿತೀವಿ. For example, say you want to add 2 digits, then we will use the mnemonic ADD, add, or else subtraction you can use SUB, subtraction. Okay, so here what we are doing, we are using something like English like statements here, right? But our computer will understand what? It will understand only the zeros and ones. So since we are using here the English like statements, there is a need of what? There is a need of translator. And in assembly level language, we use a translator called as assembler. So assembler, it is a program or a translator which converts what? Which converts the assembly language instructions into the machine level or machine language instruction, machine level language instruction. Clear? So assembler is a program or a translator which converts your assembly level language program into the machine level language program. So the disadvantage is that we need what here? We need the translator, which will cost, right? Advantage is that we can easily remember. We can easily remember the instructions, and these are easily readable, right? Easily readable, easily understandable, easy to write also. These are some of the advantages of your assembly level language. But the disadvantage is that these mnemonics were machine dependent, because if we like say example, consider I'm using one system, there I'm using add and sub, but if I switch my system to some other new system, there they may use plus minus, or they may simply use ADSU, like that. So the mnemonics will be changing from one machine to another machine, so that is difficult. So whenever a person switch from one machine to another machine, that person has to again go through the new mnemonics. So these are the disadvantages of your assembly level language. Is that clear? So these two languages comes under your low level language. Let us see about the high level language. High level language, here we will be using English statements, like English like languages we will be using. English like languages. And here the programs will be written like using the like alphabets or digits or other special symbols we will be using in the programs, other special symbols. And when I say a high level language, this is called as your third generation language. First generation is your machine level language, second generation is the assembly level language, third generation is the high level language. Here also we are using English like statements. So there will be need of what? There will be need of your translators. So in the high level language we use two different types of translator. One is your compiler and one more is the interpreter. Compiler and the interpreters. So let us study about them, compilers and interpreters. So let me give you overview of all the three translators here. So say assembler here, okay, assembler, compiler and the interpreter, right? So what will be happening here is that assembler will convert the assembly level language program, assembly level language, to what? To the machine level language program, right? Machine level language program. Here in between your assembler will come, right? Assembler is a translator which converts the assembly level program into the machine level program. The program, the which is written in our language like assembly or high level, we call that as a source code. Okay, we call it as a source code, and the machine level language which is generated by the assembler or the compiler or the interpreter, that we refer it as object code. Remember that source code is a program in which you have written, that may be your assembly or maybe high level, that is your source code, and the one which our translators converts that into, that is your object code. Okay, so now coming to the compiler, compiler will take the entire high level program at once, entire high level language program at once, and converts it into machine level code, machine level language. The word entire is important here, whereas your interpreter will do what? Interpreter will take instruction by instruction, one instruction at a time. Okay, it will take only one instruction at a time and convert it into machine level. That is the difference between your compiler and the interpreter. Hope that is clear. Your compiler will convert whole entire program at once into the machine level, whereas your interpreter will convert instruction by instruction. Hope that is clear. Now, lastly, there are two more keywords which you need to understand. One is your linker and one more is the loader. Linker is used to link the object codes which is generated by your translators. So it is used to link, or we can say combine. To combine the object files, we use linkers. To load those object file, we use loaders. Okay, to load the object files, we use the loaders. Is that clear? So that's all for this video. In this video, we have completed the parts of computer system, computer languages, that is high level language, low level language, and then compilers, interpreters, linkers and loaders. In the next video, we will see about the algorithms and flowcharts and few examples, and we will finish this lesson. Till that time, take care. Bye bye.